Question number 20. The difference between the apparent frequency of a source of a sound as perceived by a stationary observer during its approach and recession is 2% of the actual frequency of the source. If the speed of the sound is 300 meters per second, the speed of the source is alternatives are 12 meters per second, 6 meters per second, 1.5 meters per second, 3 meters per second. Here, whenever a source and a sound are approaching each other, so from the Doppler effect, we can say the apparent frequency when source and the observer are approaching each other is V plus V naught by V minus Vs into nu, where nu is the original frequency. When they are receding away from each other, then we can say mu double dash is V plus, V minus V naught by V plus Vs. So remember, this is a V minus V into nu. So when one is approaching and leaving this, then the net difference in frequency is nu dash minus nu double dash. That is delta nu is going to be. So substituting for both this equation, it is V by V minus Vs for the first case minus V by V plus Vs for the second case into nu. We have removed V naught in both this equation because V naught equal to 0, the observer is stationary. So putting 2 there, we can say it is a 2V Vs by V square minus Vs square into nu. Because Vs or V is very large when compared to Vs. The denominator, we can neglect the Vs. So the above equation can be written as so I'm going to take as delta. The difference in the apparent frequency is 2 Vs by V into nu. Because if this is V square, V get cancelled, we'll have 2 Vs by V into nu. That is given as a 2% of sound, so it is a 0.02 nu. So nu also can be removed. So we can say 2 Vs by V equal to 0.02. So we want to calculate Vs, so it is going to be 0.02 by 2 into V. So it's going to be 0.01 V. So what is V? V is given as 300. So 0.01 into 300. So 0.01 into 300. So we'll have 3 meters per second as the source velocity. So the correct answer is 3 meters per second. D is the correct answer.